Hey y'all, um, welcome to my presentation on my project for 3120. It is a inkjet printer, essentially, specifically the function that throws the droplets onto the paper using capacitors. Um, so I utilize MATLAB in order to create these simulations. And I have a couple of different programs here. The first one here is meant to essentially draw a line on the paper, while the second program ends up drawing an H. So we're just gonna run the program and discuss as it's warming up here. Um, so my GitHub, um, you should be able to find my repository there for this project, is Polaris-IPT. So you're welcome to look up and download and use that uh, freely. Anyway, so here is our simulation. Um, we have, three uh, modules here. We can adjust our parameters. We can adjust the voltage present on the capacitor plates. We can adjust the charge that are sent from this nozzle point here at the origin. And of course so for this, we have a nozzle, we have capacitor plates, and we have a piece of paper. This dot right here is just like a marking of the center of the paper. Um, so we can adjust our parameters as we see fit. I'm going to do the standard default for the project. And first things first, um, we can also adjust the capacitor geometry parameters here as well as the dots per square inch, or dots per inch. And over here we have this displays the voltage over time present across the capacitor plates, um, which, yeah, I'll run the simulation and then you'll see what all is going on here. Okay, so essentially what ends up going on here is by applying a voltage to these plates, an electric field is created there. And this electric field exerts a force on this charged particle. And by exerting a force on this charged particle, it is able to affect its velocity in this case, the z direction. So by exerting a positive voltage, I can make it go up, and a negative, I can make it go down. And as you'll see right here, if I adjust this to be 0, then we can end up with the dot simply going straight forward. And there's no adjustment in any other plane, so it simply creates a line. Yeah, you can essentially see this drop here. This, you can set the maximum voltage over here, and essentially that will kind of clamp the range on this, besides the droplets actually like hitting the plates. But if you give it more voltage, there'll be more force, because there'll be a stronger electric field, and that'll be able to send them out farther by having a greater velocity. And then they'll hit the page. So if we set this to 0, we will notice very quickly that the droplets are not affected by the capacitor at all, because it's not really doing anything. There's no electric field, so the droplets simply pass through, aren't affected, and hit the center of the plate, which is essentially what happens here and is part 1 of the project. So if we set this to 5,000, for instance, we will notice we are able to draw a line all the way from top to bottom. We can see our step for our positive voltages. We are up, and we in steps. As you can see, they are like essentially stairs. It's called the voltage staircase. It goes down to negative values, and that gives us the other direction. So that is the first simulation. We're going to look at this one, which graphs the H. So we're going to run it here. So very similar, except for now we also have a second pair of capacitors. These exert horizontal forces. So with this horizontal electric field and this vertical electric field, we can essentially exert forces to send the droplets anywhere on this piece of paper. In this case, to make an H shape. So we're going to first set our maximum voltage. We're going to set our other parameters to the same as before. Hopefully this maximum isn't too high. I had some issues with that before, just kind of sending it off screen. Let's see right here. And I think that's everything we care about. As you can also see, we have two different plots here. We have a plot for the voltage of the blue capacitors, so the Z direction control, and a plot for the purple capacitor, so the Y direction control, horizontal control. So for essentially it'll create a capital H, and the vertical line, well, you'll see, and I'll get to explaining it then. So let's see if everything is as it should be. Well, sorta and also not sorta. Let's down to 5,000. Set. We kind of want it right on the edge. I guess I must have chosen like the sort of magic number, if you were saying. The first time I did this because, well, it just worked. I don't know why it's kind of going off to the edge here, but we're going to try to get it as close as possible here. I'm not lying. This actually works. 4,500 volts. Set. Start. Okay, let's go to 1,000. Nope. Let's go to 3,500 to get our magic voltage value. Let's see. Okay, let's see what the issue could be here. 4 droplet, 20 milliseconds, down to 3,000. Set, go. Okay, well, this works. So I was trying to find the sort of magic distance here, but as you can see, it is drawing this vertical line right here, an H essentially. And it's doing this by sending the droplet diagonally. It's doing that by having an electric field from the blue capacitors and the purple capacitors working in tandem together to exert accelerations in the z direction and the y direction. Now, as you can see, it is starting to send it to the center. And we can essentially break this process up into 3 different parts. So first we have a constant voltage, like decrease, like staircase, while here the voltage is kept constant at like negative 3,000 volts. So by having this be constant while this decreases, it results in a varied value of z, while the value of y, which is just going to be essentially this point on the line here. Um, oh, moved it around. Will be set. And in this case, as we can see, it's proportional to the voltage, will be how far out this goes. And yeah, so this stays stable, constant. This one changes over time. Then we enter a point where we now have no input in the z direction, and so we just end up with a horizontal drawn line while the voltage increases as it goes from right to left. Then over here, we will then start from the top down to the bottom with the droplets, but now we have a positive voltage, which means we'll be doing the left side here instead of the right side. Of course, if this charge is negative, it just kind of reverses the process. So yeah, that is the simulation. Thank you for watching. Yet again, if you want to download this file, all these files are on there and all self-contained. So if you simply download and then plug them into MATLAB, just throw them in there, then they should work and run these simulations. So you can do these yourself. Anyway, have a good day, y'all.